Dumelang. We will continue with what we stopped with yesterday. We actually stopped at this point where we were doing surds. Okay, now how do surds work? Please note that you can simply express any surd into a simplest exponential law. So you need to check and note that the distribution of surds can only work if underneath the surd you have two factors or quotients, which are simply things multiplied or things divided. Okay, now the first one here, we have the cube root of x squared. To simplify this, we'll simply say the cube root of x squared is equals to 2. You divide that by 3. So you take the exponent that is inside the root, you divide it by the root number. So in this case, we're finding the cube root, so you will simply divide that by 3. So it'll be 2 divided by 3. So the exponents inside, which is 2, you're going to take that and divide it by 3, which is the root number. In this case, it was a cube root, so we'll simply divide it by 3. Similarly, if you have the fourth root of x cubed, it'll be x to the exponent of 3 divided by 4. If you have the fifth root of x squared, that will be 2 divided by 5. The sixth root of x to the exponent of 5 will be 5 divided by 6. Remember, you just take the root, you simply take the exponent inside the surd, you divide it by the root. Now, in this case, you will simply take 5 and divide it by the 6, which is the root number, which is the sixth root. If you have the nth root of x, note that if the exponent is not written, the exponent will be 1. Therefore, when you express this in simplest exponential law, it'll simply be x to the exponent of 1 over n. So the process continues. Let's try more examples on surds. How do we simplify this? We need to simplify this surd here. Question is, how do we simplify that? Think about it. We will simply distribute the cube root to each of the factors. So you'll find the cube root of 27, find the cube root of x to the exponent of 9, and then find the cube root of n to the exponent of 12. We'll do that shortly. We will be going through all of that. Let's start with number 1. As I've said when I started with this, you will simply distribute the third root to each of the factors that are underneath the root. So you will find the cube root of 27, find the cube root of x to the exponent of 9, and find the cube root of n to the exponent of 12. Now the cube root of 27 is quite easy because the cube root of 27 will simply be 3. However, the cube root of x to the exponent of 9, you will simply take that 9 and divide it by 3. And the cube root of n to the exponent of 12, you will take 12 and divide it by 3. Your answer here will just be 3x to the exponent of 3 and to the exponent of 4. You got it? Try this one. Simplify. You will distribute the cube root, so you'll find the cube root of -8, find the cube root of k to the exponent of 15, find the cube root of m cubed. The cube root of -8 will be -2. And you're going to have k to the exponent of 15 over 3, m to the exponent of 3 over 3. Your answer will now be -2 k to the exponent of 5 m to the exponent of 1. But remember, if the exponent is 1, we do not need to write it. So your final answer will simply be -2 k to the exponent of 5 m. Try this one. Now here you'll find the fourth root of 16, the fourth root of p to the exponent of 8, and the fourth root of q to the exponent of 4. The fourth root of 16 will be 2. What about the fourth root of p to the exponent of 8? It will be p to the exponent of 2. How did I get the exponent 2? 8 divided by 4. What about q? It'll simply be q to the exponent of 1. How did I get 1? I divided the 4, which is the exponent of q, with the root, which is the fourth root in this case. You end up having 2p squared q. That will be your final answer. Try this. You will find the fifth root of 32 and find the fifth root of x to the exponent of 5, and then find the fifth root of y to the exponent of 20. Now, what will be your final answer here? The fifth root of 32 is 2, correct. What about the fifth root of x to the exponent of 5? It'll be x to the exponent of 5 divided by 5, which is x to the exponent of 1, multiplied by y to the exponent of 4. How did I get the 4? It is simply 20 divided by 5. 20 divided by 5 will give you 4. Try this one out. Now here we're finding the square root. Square simply means 2. You will simply distribute the square root, give 100 its own square root, give a to the exponent of 6 its own square root, give b to the exponent of 4 its own square root, and give c to the exponent of 10 its own square root. The square root of 100 is, it is 10. The square root of a to the exponent of 6 is a to the exponent of 3. How did I get that 3? I simply took 6 and I divided by 2. The root here is square. Square means 2. So it means that we're finding the second root. So in this case, it will simply take 6 divided by 2. It'll give you 3. What about b? It'll be b to the exponent of 2 and c to the exponent of 5. All right, try this for 15 minutes. Press pause and come back after 15 minutes to check out the solutions. Press pause, you'll press play after 15 minutes. Now let us check here. We're finding the cube root of 64, x to the exponent of 9, y to the exponent of 12. The cube root of 64 is 4, x to the exponent of 3, y to the exponent of 4. Brilliant. Let's try this. The eighth root of negative 27, k to the exponent, actually the third root, the cube root of negative 27, k to the exponent of 18, m to the exponent of 6. How did you do this one? You distribute the cube root to each of the given vectors. We have three vectors. All those three vectors will be given their own cube root. So we'll have the cube root of negative 27 times the cube root of k to the exponent of 18 times the cube root of m to the exponent of 6. The cube root of negative 27 will be negative 3. The cube root of k to the exponent of 18 will be k to the exponent of 6. And the cube root of m to the exponent of 6 will be m to the exponent of 2. Brilliant. Let's get to the next one. Distribute the fourth root. So you will find the fourth root of 16, the fourth root of p to the exponent of 10, the fourth root of q to the exponent of 4. What is the fourth root of 16? It is 2. What about the next one though? You'll have p to the exponent of 10 divided by 4, because you need to take that 10 and divide it by 4. The last one will be q to the exponent of 4 divided by 4, which is simply 1. Now you have 2p to the exponent of, simplify that fraction, 10 divided by 4 is, it is 5 over 2. All right, that is for number 3. Let's try number 4 quickly. You find the fifth root of 243, then you find the fifth root of x to the exponent of 5, and then find the fifth root of y to the exponent of 20. What is the fifth root of 243? The fifth root of 243 is 3. The fifth root of x to the exponent of 5 is just x. And the fifth root of y to the exponent of 20 is just y to the exponent of 4. What about this one here, where we have the square root of 49, a to the exponent of 4, b squared, c to the exponent of 6. You distribute the square root again. So you will give 49 its own square root, a to the exponent of 4 its own square root, b to the exponent of 2 its own square root, and 6 to the exponent of, c to the exponent of 6 its own square root. And this is what you will end up having. The square root of 49 is 7, and the square root of a to the exponent of 4 will be a squared. The square root of b to the exponent of 2 will just be 1, and the square root of c to the exponent of 6 will just be c to the exponent of 3, which gives you 7a squared bc to the exponent of 3. All right, next we're going to be doing scientific notation. Simply will show you how to write a number in scientific notation and how to multiply numbers that are in scientific notation. All right, let's just get on with it. Now, how do we write numbers in scientific notation, and why are we doing it? Writing a number in scientific notation, it is a convenient way of writing very large numbers and small numbers. So we normally write it in this, tells you how many times a digit is moved to one digit before the comma. All right, how many times a digit has been moved to one digit before the comma. That must be a digit between 1 and 10, but it cannot be a double digit. Therefore, it cannot be 10. So it must be a digit between 1 and 10, but it cannot be 10, all right? With 1 included and 10 excluded, as it must be a unit, not tens. So in this case here, it's simply, if I'm given 2 times 10 to the exponent of 9, that 2, it's simply between 1 and 10, and 9 tells me how many times I needed to move 2 in order for me to only have one digit, as it is 2 before the comma. And in this case, there was no comma, but in the next ones, I'll show you how that. Now, what does that 10 represent? It is called a power, right? It is called a power. 10 is simply called a power. So 10 to the exponent of n is a power. Now the steps that you need to follow in writing a number in scientific notation: reduce the number to a number between 1 and 10. Count the number of times you're moving the number to the right or left so that you only have one digit before the comma. Step number 3, write the number of times a given number is moved, and that will be the exponent of 10. Nothing changes. Now let us look at this example here. Write this in scientific notation. First of all, I will put a comma right at the end. But in this case, note that I need only one digit on the left-hand side of the comma. So I only need one digit, which must be the 1. So everything must go. So I need to move that 1 to the right. So I need to count how many times I'm going to move that 1 to the right. I'm going to move it 1, 2, 3, 4, 5, 6. So I'm going to move it 6 times for it to be before the comma. So meaning that 5, the zeros, we don't have to write them. We will simply move the 5 to after the comma. So 1 will be before the comma. But for me to move the 1 before the comma, I had to move it 6 times, meaning that that 6 will be the exponent of 10. So before the comma, I'll only have one digit, which is between 1 and 10, and that digit will simply be 1. So in scientific notation, I'll simply have 1,5 times 10 to the exponent of 6. If the exponent is positive, it means that I moved my number, or the digit that is before the comma, I moved it 6 times to the right. So if you move the first digit before the comma 6 times for it to be where it is, it means that the exponent of 10 will be positive. Whenever you move it to the right, the exponent of 10 will be positive. Whenever you move it to the right, the exponent of 10 will be positive. How do we express this in scientific notation? To make it simpler to write, it's 260 million. Let's count again. How many times do we need to move that 2? So I will start by putting the comma right at the end and then move the 2. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So for 2 to be before the comma, I'm going to move it 8 times. That will be the exponent of 10. It will be positive because I'm moving 2 to the right. Okay, so I'm going to have 2.6 times 10 to the exponent of 8. We good? Try this on your own. Let's check if you got it right. So here we're moving 1. How many times before the comma? I'll just put a comma there. So we're going to move it 1, 2, 3, 4, 5, 6, 7 times. So all these 3, 5, 5 will be on the right-hand side or after the comma, okay? The zeros you don't need to write. So when we write this in scientific notation, we're gonna write it as 1,3555 times 10 to the exponent of 1, 2, 3, 4, 5, 6, 7 to the exponent of 7. So the exponent of 10 will be positive because we're moving the digits to the right. What if we got 1.6 million? Well, it's actually not 1.6 million. It's 1,600,000,000. It'll be 1,6 times 10 to the exponent of 9. Awesome. What about this one here? When moving the digits to the right, the exponent of 10 will be positive. Please write that. When moving the digits to the right, the exponent of 10 will be positive. All right, a little bit of classwork. Pause for 10 minutes and then come back. Okay, now how did you do the first one? How did you write that 15 million in scientific notation? It is 1,5 times 10 to the exponent of 7. So we move to that one. How many times? It's 1, 2, 3, 4, 5, 6, 7 times. What about this 316,500,000? You're going to write it as 3,605 times 10 to the exponent of 8. And what about this 760 million? It will be 7,6 times 10 to the exponent of 8. And this over here, 1,500,000, well, 500 million will be written as 1,5 times 10 to the exponent of 9. Here we've got 60 billion, 600 million. It will be written as 6,06 times 10 to the exponent of 10. And that's it. Well done. Let's get to the next one. We now need to expand. If I'm given 1,5 times 10 to the exponent of 6, how do I expand that? So I will write 1 and 5, and then thereafter write how many zeros? Because 5 has taken the first space, I will simply write 5 zeros after the 5. So it'll be 1, 5, and then you include 5 zeros. Okay, so that'll be 1,5 million. What about this? I'll write 2 and 6 and include how many zeros? 7 zeros, because the 6 has already taken the first place. So it'll be 7 zeros. The next one. So I'm going to write 13554. So meaning that 3554 has taken 4 spaces. I need to include only 3 zeros at the end. What if I've got 1,65? It's 165 and how many zeros? Correct, 3 zeros. All right. Write each of the following in scientific notation. Note that when moving digits to the left, the exponent of 10 will be negative. For instance, if you have something like this, 0,015, we want the first digit to be between 1 and 10. So we need to move the first digit that we can move. It's simply that 1. So we need to move that 1 how many times to the left? We're going to move it 1, 2. So we're going to move it 2 times so that before the comma, we only have 1 digit, and that 1 digit will simply be 1. So we're going to have 1,5, because as we move 1, 5 also moves. So we're going to have 1,5 times 10 to the. Okay, write this in scientific notation. Remember, you move 1 digit, all of them are moving. So we're going to move 2 how many times? Let's check. 1, 2, 3, 4, 5, 6, 7. So we're going to move it 7 times for it to only have 1 digit before the comma, and that digit must be between 1 and 10, but cannot be 10. So we're going to have 2.5 times 10 to the exponent of minus 7. Remember, when you move from the left, the exponent of 10 will be negative, okay? Do this one quickly. It's 6,5 times 10 to the exponent of negative 4. What about this one? It is 1,25 times 10 to the exponent of negative 8. The number of times you move the digit to the right hand must be, remember, the number on the right hand must be between 1 and 10, and it cannot be equal to 0. And the number of times that you move the digit to the left will be the exponent of 10. And in this case, whenever you move the digit to the left, the exponent of 10 will be negative. Okay. Classwork. Press pause Do it and then come back after 10 minutes. All right, so how do we do number one? 0,00003, well, 0,00003 will be written as 3 times 10 to the exponent of -5 because we're moving it to the left. 0,0025 will be written as 2,5 times 10 to the exponent of -3. So we're moving it how many times? It's 1, 2, 3. So that 2, to be the first digit before the comma, we have to move it 3 times. As we move 3, please note that it moves with the 5, okay? So 5 will be immediately after the comma. What if we have 0,15? We just move it 1. So that will be 0, it will be 1,5 times 10 to the exponent of -1, okay? What if we have something like this? How many times are we moving that 9 to the left? Let's count. It's 1, 2, 3, 4, 5, 6, 7, 8. So we're moving it 8 times. So I'm going to have 9 times 10 to the exponent of -8. That is, it's negative because I'm moving the 9 to the left, okay? And then what about this one here? Remember, you need to only have 1 digit before the comma. Do we have 1 digit before the comma here? The answer is yes. So we don't need to move it. So we move it 0 times. That's why the exponent of 10 is just 0. We good? All right. Now we're going to be doing operations on numbers in scientific using a calculator. Note that when you multiply scientific numbers written in scientific notation, you multiply numbers with numbers and powers with powers. So I will make it simple. What is 5 times 3? 5 times 3 will be 15, but when you multiply in the powers, know that you're multiplying the bases that are the same, therefore you must add the exponent. So you're going to write that as 10 to the exponent of 4 plus -5, which is whenever you add a negative number, it'll just be minus. So it'll be 10 to the exponent of 4 minus 5. And 4 minus 5 will give you -1. So I'll end up with having 1,5 times 10 to the exponent of -1. But note that 15 is, I'm highlighting it in red. To write that 15 in scientific notations, it means that I need to have one number before the comma. So that red one, when I expand it, actually when I reduce it, it'll simply be 1,5 times 10 to the exponent of 1. And then again here, once you expanded that 15, which is 1,5 times 10 to the exponent of 1, you now need to multiply them. So I've got 10 to the exponent of 1 times 10 to the exponent of -1. Now, because I'm multiplying the bases that are the same, I'm simply going to add the exponents. My exponents will be 1 minus 1, which will give me 0. So I'll end up having 1,5 times 10 to the exponent of 0. That's how you write it in scientific notation, okay? Because 10 is the exponent of 0, it'll be 1, so I'll just be left with 1,5. All right, let's go to the next one. Simplify this. Remember, numbers with numbers, powers with powers. So I'm going to put the powers in one bracket, the numbers in one bracket. 5 times 5. What is 5 times 5? It is 25. What about 10 to the exponent of -3 times 10 to the exponent of -2? What will that give you? So you'll have 10 to the exponent of -3 minus 2. So -3 minus 2 is -5. You'll end up having 10 to the exponent of -5. But I need to write 25 in scientific notation. How do I write that? It'll be 2,5 times 10 to the exponent of 1, because I'm just moving it once, okay? So I'm moving 2 ones before the comma, all right? And hence I'm going to have that. Now I'm going to start by multiplying the bases. So I will multiply the powers, I will multiply 10 to the exponent of 1 times 10 to the exponent of 5. Because the base is the same, I'll just write it as 10 and add the exponents. So I have 1 minus 5. 1 plus -5 is the same as 1. So I have 2,5 times 10 to the exponent of -4. How do we do this one? Nothing changes. It's numbers with numbers, powers with powers. So I'll put numbers in one bracket and powers in the other bracket. 4 times 5 times 6, how much is there? It is 120. What about 10 squared times 10 cubed times 10 to the exponent of -2? You will write it as 10 and then you add the exponents. 2 plus 3 is 5, and then you minus 2, it'll give you 3. So I'll end up having 120 times 10 to the exponent of 3. But 120 is not in scientific notation, so I will simply highlight it because I need to change that and write it in scientific notation. It'll be 1, 2. So let me check how many times do I need to move that 1 just before the comma. It'll be 1, 2. I'll need to move it 2 times. So I'm going to have 1, 2 times 10 to the exponent. I like them because I need to multiply the powers. Same basis as the exponents. 5 plus 3 is 2 plus 3 is 5. So I'll end up having 1, 2 times 10 to the exponent of 5. We good? All right. Right, numbers with numbers and powers with powers, all right? I prefer to put them on top of one another. So the numerator, I'll just put it in the numerator, and the denominator, I'll just put it in the denominator. I even change colors to show you that the numbers, I'm going to divide them separately, and I'm going to divide the powers separately as well. Now, when you divide the numbers, it'll just be 4 divided by 2. 4 divided by 2 is just 2. But the powers, though, you're going to write it as a single base, but then you take the numerator exponent, you minus the denominator exponent. Okay, the numerator exponent, you minus the denominator exponent. So when you minus, note that I'll have 10 to the exponent of minus 6 minus 5. When you minus a negative number, please note that it will be positive. So minus 6 minus 5 will simply give you minus 6 plus 5. And minus 6 plus 5 will just give you minus 1. And we don't need to simplify that too, because already it's just one digit. So we don't need to write it in scientific notation. Okay, let's get to this one here. What are you going to do? Divide numbers with numbers and powers with powers. Just write them on top of one another. What is 2, 5 divided by 2? It is 1, 25. And what is 10 to the exponent of 6 divided by 10 to the exponent of 3? So you're going to write 10 and then take 6 minus 3. So it's one base, and then you take 6 minus 3. 6 minus 3 will just give you 3. So it's 1, 25 times 10 to the exponent of 3. It's already in scientific notation. That 1,25, it's already in scientific notation. Already there's only one digit before the comma, so we don't need to simplify that. So basically this will be our final answer. Here, please remember, before you even try the division, you must first multiply the numerator separately and the denominator separately. And when you multiply, it's numbers with numbers, denominators with denominators, okay? That is before you try and divide. So I will multiply 2, 4 times 3, 2. Multiply 2, 4 with 3, 2. Remember, they said without using a calculator. You may use a calculator, guys, but be smart about it. Don't show me that you used a calculator, okay? Because I'm instructing you. Okay, I'm just going to show you how to cheat. I will say 2, 4 times 3, there. Let me just try again. Oh, there it is. And then let's see what it gives me. It gives me 1, 28. Okay, it didn't include the 2. Let me try again. 2, 4 times 3, 2. That gives me, as a decimal, it gives me 7,68. So the numbers will give me 7,68. What about the powers? The powers will be 10 to the exponent of negative 4 times 10 to the exponent of negative 3. Because it's 10 to the exponent of negative 4 times 10 to the exponent of negative 3, I'm going to write 10 and then simply add the exponents. Negative 4 minus plus minus 3 is the same as negative 4 minus 3. Negative 4 minus 3, negative 4 minus 3 gives you negative 7. You got it? That will be my numerator. So it will be 7,68 times 10 to the exponent of negative 7. Let's go to the denominator. So let's multiply the numbers in the denominator. What are we going to have? It's going to be 1,92 times it by 2. What does it give us? Here's a decimal that will be 3,84. What about the powers though? It's 10 squared times 10 to the exponent of -8. So 10, 10, multiply, you keep it as one base, and then you just take 2 plus -8, which is the same as 2 minus 8. 2 minus 8, positive 2 minus 8 will give you -6. So you'll end up having 10 to the exponent of -6. Now you're going to start dividing numbers with numbers and powers with powers. All right, let's check this classwork and do it step by step, okay? Try this one. I'll give you like a minute. So for the first one, what do you have? We have 15,19. You need to write that in scientific notation, all right? You need to write everything in scientific notation here. So when you write that 15,19 in scientific notation, what will it be? It will be 1,519 multiplied by 10 because we just moved the one once for it to be before the comma, okay? What about the 67 billion? It is 6,7 times 10 to the exponent of 10. And then for F, we have 3,003. It'll just be 3,0003 times 10 to the exponent of 0. And then what about H? Remember, we need that one to be just before the decimal. So it's going to be 1,0001 times 10 to the exponent of 4 because we're moving it 4 times to the right. Okay. Expand that quickly. Expand this, expand that, expand that. For D, please note that we're just moving it to the right because we moved it to the left, we move it to the right. When we move it to the right, it means we're going to move it just once, so it will be 0,7. For F, it means that we're moving it to the right, but we include zeros just before 7. So we're going to have 0, how many zeros? 3 zeros because 7 will be in the 4th place, okay? So it'll be 3 zeros, 0,00075. And then the 6, note that this one, moving it to the right, it means that when we moved it, it wasn't a decimal, it was a large number. So basically, we're going to include 6 and how many zeros? And 8 zeros, okay? All right, let's do this one here quickly. We are adding here. Please note that when you add scientific numbers that are written in scientific notation, we cannot add them because they're not like terms in the first place. Like terms must have the same at least number. In this case, you realize it's 10 to the exponent of 3, but the other 10 has an exponent of 4. So we can't add the coefficients because the exponents of those bases are not the same. So we have no choice but to expand. So you needed to expand that 7,6 times 10 to the exponent of 3, which will give you 7,600 plus 53,000, okay? And then you just add the 2. And here, we have done this before. How are we going to solve it? You put them on top of one another. This is what you will have. Now you will simply say 6.3 divided by 2.1. It'll give you 3. The tens will be done this before. What is the answer? You will multiply the numbers first and then you multiply the powers first. The numbers will give you how much? 1,32. What about the powers? It'll give you 10 to the exponent of -12, okay? This one here. You put them on top of one another, then you divide numbers with numbers and powers with powers. 7,2 divided by 1,2 will give you 6, and the powers will give you 10 to the exponent of minus 2 plus 4. Remember, when you minus a negative exponent, it ends in 6 times 10 to the exponent of 2. Please note that these exercises, I take them from ABC book, all right? It's grade 9 ABC book. I just forgot the authors. It's a grade 9 ABC book. It's a good book. So if you need a good practice, you must check out that book, all right? Now we're going to get into exponential equations, okay? Here we solve for unknown exponents. Let's say we've got if x to exponent, if 2 to the exponent of x is equals to 2 to the exponent of 3. It makes sense for that. Remember, the equal sign simply means sameness. It means that what you have on the left-hand side must be the same as what you have on the right-hand side, okay? Since the left-hand side is equal to the right-hand side, we've got same basis on both sides. It makes sense for both sides to be equal. The exponents must also be equal. So for both sides to be equal, the exponents must also be equal. Hence, you'll end up having x is equal to 3. Equal base, equal exponents, okay? Equal base, equal exponents. I normally call it ABEE, okay? Equal base, equal exponents. Now, what if we've got something like this? We don't have bases that are equal here. Try by all means to write 27 in simplest exponential form with a base of 3 so that we can have same bases. Once we have same bases, we can just drop the bases and equate to the exponents. What is 27 in simplest exponential form? People don't know how to do this. Do not use a calculator. I'll just show you how to cheat and make sure that the teacher doesn't even realize that you use the calculator. You just press 27 and then you press the equal sign, okay? And then in your calculator, you press shift and then you go to fact, all right? It'll simply prime factorize it for you. So you will end up having 3 to the exponent of 3. So that's what 27 is equals to. So we'll simply have x, 3 to the exponent of x is equals to 3 to the exponent of 3. And then you drop the bases, equal base, equal exponents, EBEE, equal base, equal exponents, right? Let's check this out here. What are you going to have there? You're going to do the same process, all right? So you will have to change that 25. What is that 25 in simplest exponential form? Express it as an exponential form. In exponential form, it'll be 5's on both sides. Since the bases are the same, it makes sense for exponents to be the same as well. Please note that x has to be equal to 2 for the left-hand side to be equal to the right-hand side because the bases are the same. Let's say x was 3. Away on the left-hand side, you're going to have 5 to the exponent of 3, and on the right-hand side, you're going to have 5 to the exponent of 2, meaning that you're going to have 125 is equal to 25. So they are not equal. Hence, we follow the principle that if the bases are the same, it makes sense that the exponents must also be the same for the left-hand side to be equal to the right-hand side, okay? Steps to follow: simplify each base to the simplest exponential form, all right? Ensure that the bases are the same on both sides. That is step number 2. Step number 3. All right, let's see if you get it. Let's try this one out. What are you going to do then? Prime factorize 9. That's good. Okay, try these other ones as well. All right, let's check here. You're gonna prime factorize 9. What is 9 when you prime factorize it? It's 3 squared. Now the bases are the same. You just drop the bases and equate the exponents. E, B, E, E, equal base, equal exponents, right? So we end up having x is equals to 2. Please note that here I cannot simplify the base. I can't prime factorize the 10 that is on the right hand side. However, I can prime factorize the 10 that is on the left hand side. I mean the 100 that is on the left hand side. 100, when you prime factorize it, it will give you 10 squared. You put it in brackets because that 100 is still raised to the exponent of 2. So the only thing we change is that 10 is to the exponent of 2, but it's still 100 to the exponent of x, all right? It doesn't change that, it's still 100 to the exponent of 10. Then you're gonna multiply the exponents. When you multiply the exponents, you will simply multiply 2 with x. Now 2 times x will give you 2x. So we end up having 10 to the exponent of 2x. And since the bases are the same here, you drop the bases and you equate the exponents. Remember, the exponent of 10 that is on the right-hand side is 1. If you don't write it, the exponent is 1. You will simply drop the bases and just equate the exponents. You end up having 2x is equal to 1. To solve for x there, you will divide both sides by 2. You will end up having x is equals to 1 over 2. Here, please note that you have to prime factorize both bases on the left-hand side and the right-hand side. On the left-hand side, you prime factorize 25. 25 prime factorize will be 5 squared, but note that it will be 5 squared raised to the exponent of 2. 125 on the right-hand side will simply be 5 cubed, okay? And the next step is for you to simplify what is on the left-hand side by multiplying the 2 with x, which are the exponents. You distribute the exponents. We did the distribution earlier on. You should be familiar with that. 2 times x will give you 2x is equals to 5 to the exponent of 3. And now that the bases are the same, you just drop the bases and you equate the exponents. You'll end up having 2x is equals to 3. And then you divide both sides by 2. X will be 3 over 2. What about 7 to the exponent of x is equals to 1? Now, this is a little bit tricky because on the right-hand side, you're just given 1. But the rule here is that you need to have the same basis on both sides. Now, the advantage with 1 is that you can change it to any base that you want, as long as that base is raised to the exponent of 0. So I can change that 1 to 7 and just raise that to the exponent of 0 to ensure that I've got the same basis on both sides. Now, once I have the same basis on both sides, I just drop the exponents. I drop the bases and equate the exponents. In this case, I'll have x is equal to 0. Try this out. What are you going to have? Change that 1 to 6 and make it 6 to the exponent of 0. And then you drop the bases, you equate the exponents. So you'll end up having x minus 3 is equal to 0. Then you transpose the 3 to the right-hand side. Please note that the 3, when you transpose it to the right-hand side, that sign will change. So it'll be positive. So the 3 will change from being negative to being positive. Remember, a sign belongs to a number behind it. A sign belongs to a number behind it. Behind the negative, you've got 3. So that negative belongs to 3. So when you transpose 3 to the right-hand side, it will change sign and become positive. Now, the problem here is that we've got a decimal. Question is, how do we deal with that decimal? Please watch the previous video on this where I explained how to change decimals, right? So a decimal of 0.5 can actually write that in as a fraction, and 0.5, when you write it as a fraction, I'm going to try and see if I can do it with it. There's only one decimal, okay? So let's see if we can do that. So we're going to have 0.5. I'm going to say 0.5 equals, sorry, what does it give me? Okay. it gives me a half. So you can actually use a calculator to convert your decimals, right? And in this case, it'll simply give me how much in this case? It'll give me 1/2. All right. So once you have changed a 0.5, you also need to change 4. 4 prime factorized will give you 2 squared. On the left-hand side, you will simply multiply 2 with x. And on the right-hand side, that half, you need to write it in simplest exponential form by simply writing it as a base of 2, and you just change the exponent of 2 to negative. The exponent of 2 to make it negative is equals to 2 to the exponent of -1. And then you just drop the bases and you equate the exponents. You will have 2x is equal to -1, and then you divide both sides by x. When you divide both sides by x, x will simply be equal to -1/2. What about this one here, where we have 64 is equals to 8 to the exponent of 3x minus 1. So you prime factorize 64 and then you prime factorize 8. 64 will be 2 to the exponent of 6, and 8 will simply be 2 to the exponent of 3. Then you multiply the exponents on the right-hand side. So when you multiply the exponents on the right-hand side, you will take those 3 multiplied with -1, okay? So your solution here will simply be 2 to the exponent of 6 is equals to 2 to the exponent of 9x minus 3, right? And since the bases are the same there, it will simply drop the bases and equate the exponents x minus 3. Transpose 3 to the left-hand side. It will be positive, taking like terms to one side, and you will end up having 6 plus 3. 6 plus 3 will give you 9, hence you will have 9 is equals to 9x. Then you divide both sides by 9, and that will give you 1 is equal to x. All right. This one here, how do we do it? You will simply prime factorize 32. 32 will be 2 to the exponent of 5, equal base, equal exponents, and then you drop the bases, you equate the exponents, you'll have x plus 2 is equals to 5. Once you've done that, you'll have to transpose 2 to the right-hand side, it will be negative, so on the right-hand side, you'll have 5 minus 2, and 5 minus 2 will be equal to 3.